Here we are going to discuss about how to find the LCM for binomial expressions. For an example, I'll have two values like this. Here I'm having 2x plus 4y. This is an expression I'm having, comma. Next one is 6x plus 12y. Okay, this is another expression. I'm going to find the LCM for these two expressions. I want to find the LCM for these two expressions. So initially, before finding the LCM, you have to factorize them because these are binomial expressions. No, what is binomial expression? That means more than one variable are there. So here 2x plus 2y, and in the next one 3 times x plus 2y. This would be, sorry, not 3, is 6. Sorry, 6x plus 2y. Now here also, previously we did x as a variable, y as a variable. Likewise, here you have to think the total one. You cannot split this x and 2y separately because this is in an expression. So you have to think about it totally. And as usually, you should find the LCM for 2 and 6 separately. How can we find that? Divided by 2, 3. Divided by 3, 1 time, 1 time. So LCM for these two numbers, that is 6. LCM for the numbers, that is 6. LCM for the expression. Both are having same expression, like, think about it. So this is like, this is also having a, this is also having a. Both are having a now. So that means we can directly write a. Only a. Likewise, here also 6 times x plus 2y. This would be the LCM. You have to think about the expression. This binomial expression, you cannot split that separately. You have to think about it as a whole one and find the LCM for the numbers to do the rest of the things. And thereafter, we will have another question. It is having 4 times a minus b whole square, comma 6a minus, no, we will have 3a minus 3b. This is already factorized. Look at this. This is already factorized now. So I will write that as it is. No need to expand this. This is already factorized one. In the next one, I can select 3 as a common factor here. After selecting 3 as a common factor, inside the brackets, we will have a minus b. We will have a minus b. So what you have to do, find the LCM for the coefficients. Before the expression, you are having the numbers. It is called as coefficients. Find the LCM for coefficients. 4 and 3, the LCM would be 4 and 3. 2 times 2 and 3, again divide by 2, 1 and 3, again divide by 3, 1, 1. 2 2s are 4, 4 3s are 12. Look at the expression. This is the expression. This expression having square form, the same expression is having not, there is no any square. Both are having same base, no, same variable. This is having square, it does not. So you have to select the highest power one, a minus b. This expression square. This would be the LCM for these two values. So this one LCM would be this one. Both are in ground state. So you can directly write x plus 2y. But in the next case, it is having a square. This expression, this does not. So you have to select the highest power one. So that would be the final answer. So the first one, let's do the factorization. 2 times a plus 4. And in second, 3 times a plus 4 as well. We have to find the LCM for 2 and 3. It would be 6. And both are having a plus 4 as a variable. Sorry, expression, binomial expression. So we can write 6 times a plus 4. That would be the LCM. For the second one, already factorized. So you should find the LCM for 8 and 20. So it would be divide by 2, 4, 10. Again divide by 2, 2, 5. Divide by 2, again 1, 5. Finally divide by 5. That will give you 1, 1. LCM 2 2s are 4, 4 2s are 8, 8 5s are 40. X plus 5, same base, it is having the square. So that would be the highest factorization. Sorry, highest expression to indicate in our LCM 40 x plus 5 whole square. In the next set of questions, we will have 5 times x minus 1, comma 6 times x minus 1 square, 2 times 2 times y plus 2. Okay, this expression, how can we factorize? Here also same thing. Find the LCM for numbers. Okay, other than that, all our expressions to find the LCM for numbers. We will find that 5, 6, and 2. Divide by 2. 5, 3, 1. Divide by 3. 5, 1, 1. Again divide by 5. 1, 1, 1. So it would be finally 30. 30. Look at the bases. Both are having x minus 1 basis, but the square, that is the highest one. Look at the other one that is non-identical with these two, that is the different one. So you have to denote that one. So look at this 3xy, 5x, 6x square, comma 2y. In those cases, you have to find the LCM for 562 and x square with y. No, likewise here also the third expression is totally different than the previous one. So you have to indicate that one into your LCM as well. So this would be the LCM value for here. And another kind of example we will have, that is the factorization of negative 1 as well. We will look at that. 3x, 3x, comma 15x plus 1, 15x plus 1, comma 9x minus 1. So here what you have to do? You have to find the LCM for numbers. 3, 15 and 9. We will find that 3, 15, 9. Initially it can be divided by 3. There is no any 2 multiples. So 1, 5, 3. Again divisible by 3. 1, 5, 1. Again divisible by 5. 1, 1, 1. So LCM for the numbers, that would be 45. Look at this. This is not an expression. The x is not an expression. This is an individual one. So you have to denote that. Look at this. This is having x plus 1. This is an expression. Here there is a x, here there is a x, here there is an x. Likewise, you cannot determine. This is an individual one, but these are correlated with the binomial expression. So these are not same. These x's are totally different with each other. So x plus 1, that is an expression you have to include in your LCM. But look at the other one. This is also totally different with x and x plus 1. X minus 1 means that is a different expression. No, that is the different expression. So you have to include that one also into your answer. So finally the LCM is totally this one. 45x times x plus 1 times x minus 1. So for the first question, let's do the factorization. 3 times x plus 2. Thereafter 4 times x minus 3. Let's select have to find the LCM for 4 and 3. It would be 12, and both are distinct expressions. So you have to include both of them into your answer. 12 times x plus 2 into x minus 3. This would be the first answer, first question's answer. For the second question, 5 times 5x plus 15. 5 is the common factor, x plus 3. 7 is the common factor, x minus 3. Here also 5 and 7. LCM for 5 and 7, it would be 35. Since both of the expressions are different, you have to incorporate both of them into your answer, x minus 3. And look at the last question. These are already factorized. Let's find the LCM for 3, 5 and 4. It would be 60. It would be 60 minus 1, x minus 2 is the base. That is the highest power as well. There is no any square of cubic form. And x minus 3 has a square 1. So that is the highest one. X minus 3. Yeah. So these are the correct answers for your questions. It is a different type. Okay. It is a different type than previous one. Carefully try to understand. I'm having t plus 1, 1 plus t. Here I'm having t minus 1 and 1 minus t. So let's analyze these are same or not. In here also t is having a positive mark. Look at this carefully. T is having a positive mark. 1 is positive. Here also 1 is positive. T is also positive. So these two are same. These two are same. These two expressions are same with each other. Look at the next one. Here t is having a positive, 1 is having a negative. Here 1 is having a positive, t is having a negative. So these two are not equal. These are different expressions because in the previous case also like this. But both are having plus. That means somehow the order is little different. Rather than that, the directions are same. But in here also order changed and direction also changed. If the direction is changed, we cannot determine these are equal. These are two different values. It is really important to do the upcoming question. So in upcoming LCMs, we will have 2 times a minus b, comma 3 times b minus a. B minus a. Look at this. 2 times a minus b, 3 times b minus. No, I will write it as plus. So I can write 2 times a plus b. A plus b in the same order. Here 3. Here also b is also having positive no. So I can write instead of this, I can write this one also as 3 times a plus b. So to find LCM for these two, for numbers LCM for 2 and 3 it is 6. Since both of them only the order changed, the directions are same. A plus b. This would be the LCM for these values. But when I take another example, I will take another example. So initially here we are having t plus 1, 1 plus t. Here t minus 1, 1 minus t. We know that according to their direction, if there is no any direction given, we know that there would be a positive. So positive t, positive 1. Here also positive 1, positive t. Only the order is changed. Same thing applied here as well. Look at here. A plus B, here only the order changed, but somehow here also both A and B are here, both are having same direction. So instead of this B plus A, I can write it as A plus B again. This is already A plus B. Here also the directions are same now. We are having same basis only. We can include that one into our LCM. That's why I will write this one as A plus B. I'm only rearranging this positive A come first, the positive B will become second. That's what here I did, nothing else. Thereafter look at them. Both of the expressions are same. No? For 2 and 3, the LCM is 6. Since both are having same expression, that would be included into your answer. That's what we did. So if I have x minus 2, okay, x minus 2, this is an expression. Here I am having 2 minus x. Sometimes you will think both are same. Okay, both are same. Likewise, because we had t plus 1 equals to 1 plus t. No, likewise, x minus 2 equals to 2 minus x. Not exactly because it is having positive here, but the direction is totally changed to its opposite. Not only for x, look at the y, look at the number 2 as well. 2 is having a negative value here. It became positive. So these two are unequal. These two are unequal. But we have a possibility to make them as equal. Make them as equal. We will study that one. Here I am having 2 times x minus 2. Yeah, I'm having 4 times 2 minus x. 4 times 2 minus x. If this is already in the factorized form now, I can write it as 2 times x minus 2. Look at this, only the direction. Positive became negative. Okay, positive x became negative here, negative 2 became positive 2 here. That is the one and only difference here. So, that's how I can write 4. In this 2, I can select negative 1 as a common factor. I'm going to bring negative 1 as a common factor. So from positive 2, when I divide positive 2 by negative 1, already I told you common factor means dividing that by particular number. If you are having the similar values but only one direction is changing. Sorry, if both of the directions are different. If both of the directions are different, this is the way you have to follow. So positive 2 divided by negative 1, it will become negative 2. It will become negative 2. Negative x divided by negative 1, negative and negative, it will become positive x. Positive x. Look at this carefully. 2 times x minus 2, it remains same. 4 multiplied with negative 1, it is negative 4. I will change the order only. I'm not going to change the direction anymore. I will write the positive x before, negative 2 after. Negative 2 after. Thereafter, look at them. Both are having same expressions. No, what we did to obtain this one, in the previous case we've discussed t plus 1, 1 plus t. If both are having same direction, if both values are having same direction, no need to convert them. Just change the order and write 1 plus t as t1, t plus 1 directly. No need to do the factorization, no common factor, nothing else. If both of the directions are different, positive x became negative, negative 2 became positive. In those cases, only the difference is positive x became negative x, negative 2 became positive 2. This case, you have to bring that negative. From that, you have to bring that negative as a common factor to make them as a same one. Make them as a same one. Here, that's what I did. From this, I just selected negative 1 as a common factor. After selecting negative 1, positive 2 divided by negative 1, it is negative 2. Negative x divided by negative 1, it is positive x. So hereafter, for these numbers, the LCM, that is having a negative, write the negative. 2 and 4, LCM would be 4. Since both are having the same expression, you can write negative 4 times x minus 2. That would be the LCM for the question. Try to understand what happened here. Both directions were changed. So in those cases, you have to select negative 1 as a common factor. Positive 2 divided by negative 1, it is negative 2. Negative x divided by negative 1, it is positive x. Here look at this. Here also I am not going to change the direction. I am writing in order. In an order like x positive. Here also x is positive minus 2. That's what I did here as well. Both looks like same but not exactly. To make them as same, if both directions are changed from the previous one to next one, you have to select negative 1 as a common factor to do the LCM foundation works. That is here t plus 1 and 1 plus t. Look at the directions, both are same. Here also positive, positive. So we can write this expression is equals to this one direct. If we are having t minus 1 and 1 minus t, look at this. What changed? What is the thing changed here? Positive t became negative t. Negative 1 became positive 1. So these are not same. To make them as same, this t minus 1 still remains same. Here select negative 1 as a common factor. Then it will become negative 1 plus t. Here also I am going to change the order. Negative 1 times t minus 1. We are having the same t minus 1 and t minus 1. In LCM we can get help of it. No, that's why we are doing this step. Next, one more type there, t minus 1 and t plus 1. Look at this. Here, t is positive. Here also t is positive, but here 1 is negative, here 1 is positive. So these two are also not same. We cannot change them as either. Here you can directly write 1 plus t as t plus 1, as t plus 1. In the next case, if both same, both same, both directions are same, that's what meant by both same. Here both different, both directions are different for both variables. In here only one difference, only one difference. In this case we cannot do anything. You have to use this both, use both of them, because previously we had x plus 3 and x minus 3. In those cases we have selected both of them to our, both of them were included in our LCM. No, that's what we did before. And after that we did something like this, the changing the only order. And if both of the directions are different, you have to select the negative one as the common factor to do the rest of the thing. That's all.